So now you understand we were on the Lechateliers principle. So that was the last part of the Lechateliers principle. Now, what does that say? Understand. Lechateliers principle. Lechateliers principle. And we were on the addition of inert gas. Addition of inert gas. Yes or no? Addition of
Yes.
inert gas.
Yeah.
And how was that exactly? So addition of inert gas, isn't it? And it would exactly mean what? I had given you the two options. One was when you add inert gas at constant pressure. At constant pressure. And one was when you add inert gas at constant volume. So both of them had different impacts and both of them would shift the equilibrium to different situations. So
Right.
at constant pressure and at constant volume.
Yeah.
So how would that be? Just understand. So when I say addition of inert gas at constant pressure and at constant volume. Now just have a look. So it would be something like this. Right? Now, what is happening? Now let's suppose this is a beaker. This is a beaker. And there is some gas I have filled already. This is my original gas. This is a non-inert gas. Non-inert as in it could be oxygen, it could be anything. And
Okay.
this is going to be the top of the beaker with the piston. Okay, this could be the top with the piston. Yes or no? When
Right.
this is the top with the piston, what exactly is happening? Just understand. So I have somehow, been able to insert helium. Now, what is helium? Understand. So this was the reaction. So this was the reaction N2 plus 3H2 to give me 2NH3. All right. And what do I do? I know that obviously, these gases are there inside. So I have 1 mole of N2, I have 3 moles of H2, I have 2 moles of ammonia. So these gas molecules are definitely there, isn't it? And
Right.
these,
Yeah.
so I have all of these inside. There are some molecules of N2 also, some molecules of H2 also, and some molecules of ammonia as well. So what exactly is happening? What exactly is happening? That these two are combining to form ammonia. And I have added helium at constant volume. Now, what is at constant volume? Understand. See, understand. If I add few extra molecules of helium inside it. So I hope you're understanding that let's suppose these are the helium. The red dots are actually the helium molecules or helium atoms. So don't you think that these helium atoms would require a lot of space? These helium atoms would require a lot of space, isn't it? So when you add helium inside, obviously you understand that helium is not going to react with any of the reactants. Helium is not reacting with any of the reactants, neither nitrogen, nor hydrogen, nor ammonia. It is not reacting with any of these. You understand? But
Right.
what is happening? But what is happening? That helium is actually being added, so the net pressure inside is increasing. So the net pressure inside increases. Obviously, and what am I doing? I am not allowing this pressure to, relieve. I'm not allowing this beaker or this piston to actually move up. I'm not allowing that to happen. Because if this piston would move up, what would happen? Just tell me. So the piston would actually move at a higher position and the pressure will thereby fall, isn't it? And the volume will change.
Right.
If the piston moves up due to the extra pressure of helium, the piston will move up. No doubt on that. It will. So helium, when we have added helium inside it, obviously there are other molecules as well. These are the black molecules were the original molecules which are there in the beaker. And they were some atoms of hydrogen, some of nitrogen, and some molecules of ammonia were there, isn't it?
Right.
So what do you think we have? We have right here, we have the red dots are basically helium that we have added from outside. So the pressure inside would thereby increase, and that pressure will push the piston upwards. But what have I done? I have applied these nails right here. So these nails will not allow the piston to move up, because if the piston moves up, so this would be the scenario, this would be the case. And if the piston moves up, I hope you're understanding, we get more volume. But what is the heading? Read the question. The heading is addition of helium or any inert gas at constant
Constant.
volume.
Right, right.
So I am not changing the volume. The volume was initially also VI and the final volume was also VI. I hope you're understanding.
Yeah, yeah.
And when the volume, initial and final volume, both of them are VI. So I hope you're understanding when I write down the K equilibrium, I hope you're understanding that shall be NH3 whole square over H2 concentration raised to power 3 into N2 raised to power 1, isn't it? So H2 is raised to the power 3, N2 is raised to power 1. Why? Because the coefficient of N2 is 1. The coefficient of H2 is 3. The coefficient of ammonia is 2. I hope you're understanding.
Yeah.
So we write down product over reactant. That's how we are writing it down. And when we are writing product over reactant, what does that mean? Just tell me. What does that mean? It would mean that, ma'am, that is how the concentrations would be. And what is square bracket ammonia? This square bracket ammonia means the moles of ammonia over the volume of ammonia. Are you understanding? And the moles of ammonia and the volume of ammonia, what does that mean? The volume of ammonia is not changing at all. And
Right.
helium,
It's
when
not.
you add inside the system, helium is also not reacting with any of the molecules because helium is an inert gas. Inert
Right.
gases do not react with anybody. Inert gases do not react with anyone. Do not react with anyone. So, what does that mean? What does that mean? Tell me. It means that helium will not make any changes in the concentration of any of the reactants or any of the products. So you must have understood one thing, that if the concentration of any one of them falls, it's like taking out ammonia from the beaker. That's what you mean by the concentration fall in the ammonia concentration.
Right.
Or if I reduce the concentration of H2, that would mean the reduction in the concentration of H2. You understand? But there is no change in the volume. So no change in the volume means no change in the concentrations of either hydrogen or nitrogen or ammonia.
Right. Okay.
And thereby no change in the equilibrium constant. So basically, you will simply write no change, because inert gases at constant volume do not bring any change in the already established equilibrium.
Okay.
You understand? But now,
Yeah.
if I say I have added a noble gas, I have added a noble gas at constant pressure. What do you mean by at constant pressure? At constant pressure means that I have this particular beaker. And when I have this particular beaker, I have certain molecules of N2 and H2, 3H2, to give me NH3. That's my equation, isn't it? And when that's my equation, so I have this time, this is my piston. This is my piston. And this particular piston that I have right here, and I have these gases working inside. So these gases would be N2 plus 3H2 to give me 2NH3. And we have this equilibrium reaction. The reaction is going backward, forward, and backward both. Are you understanding?
Yes.
So now what do? I add in from outside some more molecules of helium. So these red molecules are the molecules of helium, and these blue molecules are already the molecules of N2, H2, and ammonia, between whom the reaction was actually taking place. Yes or no?
Yes.
So what do you think would happen now? Now I have not added up any nails here. No nails. So this
Right.
piston is basically free to move. This piston is free to move.
Yeah.
And when this piston is free to move, I hope you're understanding, the moment you add extra helium inside it, obviously the pressure inside the piston will rise. And when the pressure inside the piston rise, but the heading is at constant pressure, the pressure should not change inside. But we have increased the pressure inside because we have added helium. So what do I say? So addition of helium. So addition of helium increases the pressure inside the beaker. Okay? Increases the pressure
Yes.
inside the beaker. Are you
Right.
understanding? So when the addition of the helium gas inside the beaker increases the pressure, and for example, if I would have applied these nails right here, then what do you understand? That these nails would not allow the piston to move up. So the pressure would remain increased inside the beaker. But this time I have not applied any nails. So that means the moment the pressure increases, that extra gas pushes the beaker upwards, pushes the piston upwards, isn't it?
Right.
And when
Right.
it
Does.
pushes the piston upwards, what do you think would happen? Just tell me. When it
The
pushes the
volume would
piston upwards,
increase.
the volume will increase. And when the volume
Right.
increases, so this piston, basically this graph, this box was there. So now the piston has reached here. The piston has reached here. What is this situation? The volume has increased. Earlier, this was the initial volume. Now, this is the final volume. So don't you think the final volume has increased? And I have
Yes,
done
it has.
nothing. Helium when it goes inside, it does nothing. It doesn't react with nitrogen. Helium, it doesn't react with hydrogen. Helium does not react with ammonia. So helium is actually not reacting with any of my reactants or any of my products. But what is happening? Helium is actually forcing the piston to move upwards. Are you understanding? And when helium forces the piston to actually move upwards, what do you think would happen? Just tell me. So ammonia, if in a particular reaction there were initially 10 moles of nitrogen, 40 moles of hydrogen, and 60 moles of ammonia, do you understand now the volume has increased? So at initially situation, I would write down the K equilibrium as ammonia's concentration raised to the power 2 over nitrogen's concentration raised to the power 1 over hydrogen constant raised to the power 3. And what was that concentration? That concentration was number of moles over the volume. That was my concentration of nitrogen, isn't it? So,
Right.
but
Yes.
helium has not actually reacted with anybody of them. So, nitrogen, if it was 100, if it was 10 moles initially, then even now nitrogen's mole have still remained 10 moles. And when nitrogen's moles have remained 10 moles, what do you think would happen? Just tell me. What do you think would happen? Nitrogen's mole have remained 10 moles, isn't it?
Yeah.
So what do you think would happen? So now the volume has increased. So 10 over, let's suppose initially the volume was 5 liters and now the volume has become 10 liters. So number of moles still remains 10. So earlier the concentration was 10 over 5. You understand? And now the concentration has become 10 over 6. Isn't it? So the
Right. Yeah.
concentration of every reactant and product is actually decreasing. And then you will have to see down that whose impact is more. So if the net reactants power is more, if the net reactants power is more, I hope you're understanding. So basically, increase in the volume is giving more space to nitrogen and hydrogen. Are you understanding? And
Correct.
when it
Yeah.
is giving more space to nitrogen and hydrogen, so they would acquire that status where they want to remain four molecules rather than two. Are you understanding? You understand? So they will move
Yes.
backward because now you're providing with more volume, and more volume allows more molecules of the reactants or more molecules of the reaction to stay like that. So, for example, if we have more number of molecules, what would that mean? Just tell me. That more space allows more molecules in the reaction to actually accommodate. So the reaction will move to that side where there are more number of molecules. So increase in volume is as good as, decrease in the pressure. Increase in volume basically at constant pressure basically means why the piston is actually trying to move up. I hope you're understanding. And when the piston tries
Right.
to move up, it is in the process of restoring back that old pressure, because helium, when we have already added, has increased the pressure inside. So when it has increased the pressure inside, I hope you're understanding that this particular increase in pressure will do what? Tell me. This particular increase in pressure will push this piston to move upwards, and this upward movement of the piston will try to restore back the pressure, thereby providing more volume. And when you have more volume for the particular reaction, the reaction will move to that particular side where there are more number of molecules. So in this
Okay.
example, the more number of molecules are on the reactant side. So the reaction
Right.
will tend to move towards the backward side. So that is how you decide the impact of the addition of noble gas at constant pressure. I hope you're understanding.